All right, so we're moving on to mesh analysis. I don't want to take the time to go through another lengthy example with a ton of algebra. I think we've done quite a bit of that already, and it's probably starting to bore you. So instead, I'm just going to do a brief review of mesh analysis, kind of show you how to set up the problem. Hopefully those of you, again, who remember this from EE 220 shouldn't be too difficult, but I'm going to run through it anyways. So let's say we have kind of our same circuit from the last problem. Let's say we've got a voltage source here, V1. And then let's just say we've already converted our circuit into the phasor domain here. So I've already just got everything written out as impedances. And I got another source here. All right. My bottom little wires here look pretty ugly. Let's fix those up. All right, so this is my circuit. I'll call this V2, and let's call this Z1, Z2, and Z3. And then let's define our currents. So that's going to be step one here, right? For mesh analysis, the first step is we define our loop currents. So we've got two loops, so let's define one current flowing this way, and let's define one flowing this way. In AC, the circuits aren't flowing in a direct current way, like they're not DC signals, but it doesn't matter. We can still define current direction. It's really just a mathematical tool to solve these circuits. But just so you know, I'll define my plus minuses the same way that I did previously, where current flows from plus to minus through the impedances in this case. And then I'll define my plus minuses for the sources as such. And then from here, you would just go ahead and set up your loop equations by writing the KVL expression for each loop. So that's going to be step two. So for the first loop, it's going to be, I'm going to start right here, and I'm going to go this way. So going across the voltage source, I'm going to get V1. Then I'm going to drop across Z1, right? So I'll go minus I1 times Z1. And then I'm going to drop across this impedance Z2, but I have two currents flowing into this node, right? I have I2 and I1, so I have to sum those, right? So it's going to be minus I1 plus I2 times Z2, and then all of that is equal to 0. All right, for the second loop, I'll start right here, and I'll go this way. So I have V2 first. Then I drop across Z3, so I'm going to write minus I2 times Z3. And then lastly, I have the same term that I had from the first loop. All right, so I end up with this system of equations here. I've got a bunch of known values, right? We would know V1 and V2 in a circuit like this. I would provide you with either the time domain or the phasor domain values for these sources here. And then we would obviously provide some components, so you would know all these impedances, and so all you'd be left to find would be I1 and I2, and you can do that by solving the system of equations here. So you would go through this, solve the system of equations, and you would end up with a value for I1, and you'd end up with a value for I2, and then you can go back and solve for, say, this voltage, which is what we were trying to find in the previous case, and you would do that, and you should be able to determine the value of any voltage and any current in the circuit by doing that. Okay, so that's the kind of overview of mesh analysis. So I'm going to go ahead and stop that there, and then I'm going to go into the next couple of videos talking about Thevenin and Norton equivalent circuits, and then source transformation. And we're going to try to wrap up this module pretty soon. So I'm going to go ahead and end this video here.